Greetings, participants. On behalf of the ECE Department of Xavier Engineering College, I extend a warm welcome to all the participants present here. Wisdom is not a product of schooling, but of the lifelong attempt to acquire it, a quote by Albert Einstein. I request Mrs. Navneetha Velamal, Professor of ECE Department, to commence the session with a prayer.
Ourselves in the presence of the Lord. Dear Father, we thank you for this opportunity. We thank you that you know each of us by name and have caused us to walk with you. We say that we are dependent on you and our trust is in you completely. Open our minds so that we may receive your eternal wisdom. Open our spirits so that we may know your leading and guidance. Open our hearts so that we may receive your wonderful love. Dear Lord, we thank you for our speaker and our management, Chairman Sir, Vice Chairperson, our Managing Director, and all our higher officials for providing space for giving this opportunity to conduct this webinar session. Your presence be with us throughout this webinar, guide us and lead us. We ask in this name of Lord and Savior Jesus Christ. Amen.
Thank you, ma'am. Now I invite the head of the Department of Electronics and Communication Engineering, Mrs. Friska ma'am, to introduce our resource person.
A very fine good morning. The fear of the Lord is the beginning of wisdom, and the knowledge of the Holy One is understanding. First of all, we would like to thank our Lord Almighty for His showers of blessings on us and enabling us to organize this webinar on robotics and automation. We would like to record a sincere thanks to our management, higher authorities of Xavier Engineering College in motivating us in all our endeavors. I am very much pleased to welcome all the participants who have joined us across the state and from other countries. We are happy to inform that Department of ECE Xavier Engineering College is organizing series of webinars through our department expert team, industrial experts, our alumni, and so on. I thank all my ECE department faculty members and coordinators of this event, Professor Navneetha Velamal Madam and Professor Kannan Sir, for their commitment and dedication in organizing this event. The ECE Department of Xavier Engineering College shapes students for careers in this constantly changing environment, such as fiber optics, remote sensing, VLSI design, digital design, robotics, automation, etc. The department is NBA accredited and has produced 23 Anna University rank holders in past 3 years. The Department of ECE has received a grant of Rs 45 lakhs from Department of Science and Technology, Government of India. I feel extremely delighted in introducing our resource person, Professor Amarsingh Feroz, Department of ECE, Xavier Engineering College, who is a fountain of knowledge. He would be giving us lots of practical ideas we can immediately put to work. Sir has completed his BE in Electronics and Communication Engineering from Madurai Kamaraj University in the year 1996 and his PG degree Digital Communication and Network Engineering from Anna University. He has more than 15 years of teaching experience and more than 4 years of experience in various industries. His area of interest include networking, embedded systems, security, robotics. He has published more than 20 papers in Scopus Index and SCI journals, a person with rich practical experience and one who has molded the career history of so many of our students is with us to share his expertise. So I don't want to take much of his time. Now I hand over the session to Professor Amarsingh Feroz, Department of ECE, Xavier Engineering College, for handling this session on robotics and automation. Thank you.
I welcome you all for the robotics and automation webinar. And today, robotics is one of the very hot and trending field and also one of the integral part of Industrial Revolution 4. Today, in the coming minutes, we will be going through a brief introduction about the robotics, how robotics evolved, what are the bases, and then we will talk about the basic building blocks of the robos, the subsystems, and how robos are classified based upon a variety of applications, talking from the past to the future, its types, then the technologies at present that are ruling the robotics field, current trends, then we will discuss about the courses one can take to have a career in robotics and some basic projects a beginner can do in the field of robotics. The word robo is coined by Czech novelist Karel Čapek in the year 1920, meaning it is worker or servant. Okay, so a proper technical definition is a robo is a reprogrammable multifunctional manipulator. It is designed to move materials, parts, tools, or specialized devices through variable programmed motions to do n number of tasks. So it is a reprogrammable one. We can program according to our needs. It is a multifunctional one. We can do as many functions with that. It is a manipulator. So through this we can move materials, any tool or any devices to do a variety of tasks. This is a basic introduction of a robo. That figure you are seeing is the Czech novelist Karel Čapek. So ASIMO in the year 1940s proposed some laws for robotics in the sense that robo designed by humans should not harm the human, should not injure the human, should coexist with that, and also it obeys the instruction of the human being, and it should also protect its own existence. Based on these laws of robotics, up to now robos are designed. So ASIMO, you can call him as one of the father or founders for this robotic field. He gave a very great propelling forward for this field. So we will be talking about the subsystems. How or what are all the integral part of a robo? We will be seeing about that. So basically, Robo Subsystems consist of motion, recognition, and control. Motion is related with movement, as you can see from here, motion subsystem. And recognition, you can see to identify the objects, and then how to control the motion based upon recognition. So motion subsystem, recognition subsystem, and control system subsystem. Broadly, we can classify robos into these three basic subsystems. So motion subsystem, in that we have a manipulator, means it's a mechanical arm plus wrist. It is used to manipulate materials without physical contact. So it's a mechanical arm and a wrist. It does many functions multifunctional simultaneously, or it performs various tasks. That is what we call it as a manipulator. End effector is a part of a robot that it interacts with the environment. For example, robotic hand gripping a torch, welding torch, a painting brush, so to remove tools, that and all we can consider as an end effector. The next part is actuator. Actuator is the muscle of the robot because it converts energy, especially electrical, into physical motion. It may be a pneumatic one, hydraulic one, or an electric one. So the diagrams are here. Basically it is a DC motor, a servo motor, or various types of motors that gives power to the arms to perform a particular task, that gives power to the robot to walk, to do any actions. So that part is the actuator. So that's what we call it as a muscle, because muscle gives us strength, isn't it? And the next one is the transmission part. It transmits motion from prime mover. So this muscle, this power makes the arms to do certain task, rotation of the wrist. For that, if we design a robotic arm, we need some gears, or we need some belt or chain drives, or some link mechanism. So that part is transmission part. The next one is sensors, comes under recognition subsystem. So recognition, face recognition, sound recognition, so temperature, contact sensor, proximity, distance, pressure, tilt sensor, this all comes in the under the recognition subsystem. Basically, recognition subsystem are transducers, okay, and also analog to digital converter, some electronic devices. This all comes under recognition subsystem. The next one is control subsystems. So for controlling, for example, a central processing unit, memory, hard disk to store programs. If we talk about from the practical aspect, an Arduino board which has a memory, which has a processor, okay, and a basic embedded kit through which we can store some programs, a ROM, and also interfaces, digital to analog converters, and amplifiers. So these are all the controlling part of a robo subsystem. So broadly, robo are classified into motion control subsystems and recognition subsystems. Okay, so next we will talk about the classification of robots. So robots, based upon n number of applications, robots are classified. So first we will talk about the industrial classification. It is a very wide one, and then we will talk about non-industrial purposes. Okay, so industrial classification, when we talk about that, the definition behind that is it is an automatically controlled and a reprogrammable one. It is a multi-purpose manipulator, programmable in 3 or more axes, and it can be fixed or mobile. So it is an automatically controlled reprogrammable one. Say for example, for painting of a car part, it is programmed. So as soon as the car part particularly it comes in the conveyor belt, it automatically sprays the paint over that. That too in packaging industries and in all industries we can find this sort of robotic applications. For welding purpose also, for picking up tools and putting it in proper places, we can use this sort of thing, industrial purposes. Next one, we will talk about this industrial robots in the coming slides in more deeper. Next we talk about some non-industrial applications also. Okay, so non-industrial or special purpose applications. First we will talk about medical, because the robots field of robotics inside in the medical is something vast and extraordinary, and more benefits are for the human community. So the first thing is Da Vinci surgical robot. This is shown here in this diagram. It is a surgical one where it can operate on patients. It's actually a virtual one where there is a monitor and a doctor will be operating virtually the arms, and based upon the movement of the doctor, the arms will go and do the operations in the patient. It will cut the skin open, it will sew the particular skin, everything it does. So Da Vinci surgical robot. Next one is germ sampling robot. So this type of robots nowadays finds enormous application in this COVID-19 scenario, especially for cleaning ICU beds and for cleaning hospital premises. It will impact the minimize of healthcare workers also. The next one is endoscopy board. These are all recent. You know about the endoscopy procedure. It's really tough, and many people doesn't like that also. By inserting a tube fitted with a camera, and it's somewhat painful. Some feel really bad about that. But you can see from this diagram, it's actually just 2 centimeters, and it is fitted with a camera inside, and you can swallow just like that, and you can control also, and it will go to the minute part of the intestine, and it will clearly get a very great picture or image of what's happening inside. Okay, so this is one of the very major breakthroughs in endoscopy. And another one is disinfectant boards, where you can see that to disinfect the patient wards, general ward, ICU, and other corridors in the hospital. Especially it finds its use in this coronavirus COVID-19 scenario. Okay, and another most important application where you can see here is exoskeletons. One you are seeing there, and you can see over here exoskeletons. This finds extensive use, like suppose if a person has a spinal cord injury, and due to that he is not able to move his arm and leg, and he is not able to walk, and he is bedridden. If you take like that, what happens is you can have this sort of arrangement. You have a battery backup pack connected with wires. Suppose if your thigh and leg movement is not there, you can fit over here, and it will give power to the legs, so that the person can just walk normally. Imagine a bedridden patient with a spinal cord injury, not able to walk for the rest of the life, can walk through this extraordinary invention, exoskeletons. So this also finds use in, say for example, if a person has lost his arm, lost his leg, he can be fitted with a robotic arm and robotic leg, and it will power the person like that. Also for soldiers who are carrying heavy loads in highly dangerous terrains, especially in climbing mountains, they will be having a very huge backpack. they can wear this exoskeleton so that it will give them additional strength to carry heavy loads. So this is such a good invention where it can be used in medicine or and also in military also. Then you see this companion boats that you can see it over here, the white color one. This companion boats imaginally, basically what happens was when a person is affected by sickness and it is in, if he is in ICU, basically he feels a lot lonely also. These companion boards are designed to interact with the patient, to understand about the patient, to be a comforter to the patient, and also in providing timely medicines and care. Okay. Then the robotic nurses. So imagine a hospital overflowing with lot of patients, and nurses find it very difficult to keep the registers, give medicines to the patients at the time. So this sort of work can be done by robotic nurses. It's already there, and now it finds extensive use in this COVID-19 scenario. Then robotic assisted biopsy. So imagine a cancer patient undergoing a biopsy. Now robots can do this biopsies also. So especially protecting the healthcare workers. The next one in the classification based upon space explorations. So robots find extensive use in space. For example, the NASA, when it launched the Mars rover, it is a robo, and now NASA is in the process of making another robo to be launched. So most type of land rovers are robos only. Okay, so what it does, it takes measurement for astronauts, they collect samples, they assemble and fix equipments, and also in the International Space Station, robots are there to fix all problems in the space station. So such is the foray of robotics into the field of space. Next one are defense robots. There are n number of defense robots. What I have put is something very new. So one is a bomb disposal robo, right? What you are seeing in the left side. This robo is used by United States to dispose the bombs as well as to catch people who are troublesome or suspects or terrorists. So these robots are extensively used. And another one is transportation robots, what you are seeing in this picture, where it can carry heavy military equipments in dangerous terrains. Literally it's not possible for a soldier to carry or for another armored vehicles to go. These sort of robots can be used. So apart from that, there are a number of defense robots are there. The next one is robots used for security. So surveillance, unmanned aerial vehicles for power surveillance in power generating plants, oil refineries, which are a threat from terrorists, or to monitor borders, we can have this sort of robots. Okay. The next one is robots in domestic purpose. Robots in the field of home, in the home house purpose. So there are many robots, especially robots are there for making rotis, robots are there for making dosa, robots are there for making vacuum cleaners. One is Roomba. So it is a highly autonomous robot where you can just suck the dust, and also you can wet the floor also using this Roomba vacuum cleaner. It will go underneath sofas, go into the corners, and it will clean like a professional. And also robots are used to clean toilets. One robo is the scrub mate is there. That sort of robots are there. And what you are seeing here is Lovo it's one of the recent robo in domestic purpose. It is actually a friend and a domestic assistant. Usually people who are very old and who are staying at home alone, and those people have this robo as a friend, where it gives a calming, it comforts them, it gives a therapeutic presence, it reminds the person to take the tablets. It is somewhat talkative and interactive with that. So something fun to play also for people who are very lonely at home. So this type of robots comes under the domestic category. The next one is classification by degrees of freedom. So it comes under industrial robots. So degrees of freedom means how a robotic arm can move in different directions. Means it represents location as well as orientation. So this sort of robotic arms are basically pick and place. You pick an object and place the object in other place. That sort of robo. Say for example, suppose if in industry, if we have to take a product or a part from one assembly line and place it into the next assembly line, we can have this sort of robo. Mainly in manufacturing process, it is a common scenario where some parts comes in one portion and it has to be shifted into the next conveyor belt to be processed for the forthcoming process. So degrees of freedom in the sense that, as you can see the first diagram, you can see that there is a waist rotation, and then there is a shoulder rotation, and then there is an elbow rotation, then there is a wrist rotation, and then there is a gripper rotation. So here we can see about 5 degrees of freedoms. Basically we can talk about 5 joints also. So if we take an arm, our arm, we have a shoulder, so the shoulder itself rotates. We have a elbow, the elbow also rotates, and we have a wrist, the wrist also rotates, and also our fingers, the finger also rotates. So these sort of movement, it represents our orientation, how we are going to take an object, place an object. So degrees of freedom represents this. So there are 3 degrees of freedom, robots based upon 3 movement, either elbow joint, wrist rotation and grip rotation, or 5 degrees of freedom, or the next one where we are showing 6 degrees of freedom. Some when we design an arm, some arms can rotate 360 degrees, some joints just like that. Okay, this is one of the most important classification based upon degrees of freedom. So sophistication in industrial robotics is based upon one of the parameters is degrees of freedom. The next one is classification by kinematic structure. So word kinematics basically refers to coordinate systems. Okay, so there are different types based upon this kinematics. One is Cartesian, means when the arms of a robot moves in x, y, z coordinates. Okay, we call that as a Cartesian robot. So you see there an x-axis, y-axis, and then an z-axis. This sort of robot. So this is one type. The second one is robots based upon this kinematics. One of the types is cylindrical robo. So you can see this robo has one basic rotation, so it rotates, one elevation, so it lifts up, and one reach, so it places and picks the object or puts it in some place. Okay, so what you are seeing is a robo of a cylindrical nature which is used in welding. Okay, that's the figure. So the next one is spherical. So similar to this cylindrical robo, so it also does that. It has a base rotation, an angular elevation. So elevation in a particular degree and then a reach. So it puts the object in a 30-degree reach, or it elevates itself in a 30-degree and places it there. So that sort of spherical environment. Okay. The another classification, and one of the most important classifications of kinematic structure based, is SCARA, Selective Compliance Arm for Robotic Assembly. Okay, SCARA. So the example for SCARA, this one is palletizing. So this SCARA has two parallel revolute joints, means it provides a flexible behavior in response to external forces. So in mechanical, palletizing is one aspect where you can see this in the assembly line. So the next classification of this based upon kinematic structure, and one of the most important also, is articulated, also known as, this one is anthropomorphic robo arm that has 3 revolute joints. So you can see that one this type of robo basically is one used for forging. Okay, you are seeing over here. So for forging and all, we are using an articulated type of robo classification based upon kinematic structure. Okay, the next type is classification by movement. Classification by movement. So we are seeing here. So one is a fixed one, it moves in certain degrees of freedom. Another one is mobile, it's not fixed, it moves over the surface. So when we talk about mobile, there are either a legged robo there or a wheeled robo there. The one you are first seeing here, it is a wheeled robo, single wheel. Its name is Seiko from Japan. The next one you are talking about is, it's a four-wheeled robo used by NASA for the space. And then we are seeing a three-legged robo, so it's also a mobile robo. And then we are talking about a six-legged hexapod structure. You are seeing this, it can carry weight, we can use this to carry heavy equipments or machinery to other places, or in from one workshop, from one floor to next floor. These sort of things we can use it. Robos based upon movement. Then this list is quite exhaustive. Then we can categorize robo that is used especially in water, underwater thing. So one that is recently shot to fame in 2019 was an aquanaut invented by NASA in their labs. It's an unmanned underwater vehicle. Okay, you are seeing this. When you see this, it looks like a robo underneath, but it will transform just like a submarine also, where it travels and it fixes faults in oil and gas, undersea infrastructures, cables. It fixes the valves there, and it can use tools to do all these things. Okay, so this one is a very recent innovation. And then the another one, that yellow color one you are seeing over here, it is a liquid robotics. It is a wave glider used in Pacific Ocean to study the ocean exploration. These types of robots are used. You will be quite astonished if you hear this robo has traveled 17,000 kilometers in Pacific Ocean to study about the ocean. Okay, so this is currently in use and extensively used by the Ocean Department. Okay, the next types, basically it's all related with our human nature, humanoid robots. So when we talk about the growth of robotics, at present the robos plus artificial intelligence have joined together in the in resulting in this humanoid type of robots. Okay, so one of the best, there are so many things are there. So one of the best is ASIMO. It is a humanoid robot invented by this Honda company. So it will run, it will dance, it will even kick a soccer ball. If you command, it will fetch you a glass of water. It will help elderly people. So this sort of robo is such a wide popular robo. Another one is ILA. It's a humanoid robot used by researchers. These are all latest. There are so many things out there. It has an artificial intelligence. It has a robo perception. It perceives there, and also you may have seen in web Sophia, a humanoid robot used for news news reading. This Sophia can also interact with humans also. It has a very good memory. If you can Google, you can see that Sophia interacting with a person 6-7 months back, and then it still remembers the person when it meets again. So just like our human brain, which has a memory, when we recall people from the past years, when we meet after 5 years or 10 years. So based upon our human lines, these robots have been designed. So the next one we are very much aware of is a self-driving car or an autonomous car. So here you are seeing a Google self-driving car. So we know that it has taken this car travel without drivers into a next level. Okay, so to develop technology to reduce traffic accidents and to increase road efficiency. Okay, so the next one is telepresence. Usually when people walk in remote places, work lonely, they quite often find that I'm only walking. So this telepresence robot has an autonomous mobility with a video conferencing, and it helps workers to make them motivated, engage them in talk as if though there are more than two people are working, taking out the lonely thought from the concerned worker. So ABBA is a telepresence robot. This is the recent robot. There are many telepresence robots are there, but this is a very recent robot widely used over here. Okay. The next one, robots in the field of education. So when you see this, there are many robots that have been extensively used. For example, robots are used to make the students learn alphabets, to make the students learn how to draw, how to pronounce, how to learn languages, how to identify objects, everything. This sort of robots are there. But recently, cubelets. This is one sort of robot which is a magnetic blocks which can be together to make different variety of robot without any programming. This robot will respond to light, will respond to sound, will respond to temperature, and we will be astonished. It has a just like a human lifelike behavior. Okay, so if there is a bright light, immediately our eyes will shut, isn't it, in order to protect. The same way these robots also behave depending upon the variation in light. So the next thing, robots in the field of disaster response. There are many robots that have been used, especially during earthquakes. We can see that even if a child um, fell in a borewell, you can take the child using a robot. We have seen, you might have known about that. But this is one recent robot which looks like in the form of a snake, and it goes to places where no human can go, maybe in underwater or maybe in harsh terrain environments. you can have this sort of robo hazardous environments. This robo will screen the particular area and give a appropriate information regarding this. So the next one is Robos Robotics. The recent trends. We have seen about the different classification of robots. Now we will be talking about what is the current scenario, because you might be very eager to know about this recent technologies. Okay, so we will see some recent trends that you will be very astonished. One thing is artificial muscles. So we found out that actuators are motors that gives power to the robo. Imagine a robo having a muscle like us. So this is based upon carbon nanotubes. Okay, so these artificial muscles will just sense as like a human. Okay, suppose if someone touches us, we know whether they are touching in a friendly manner or whether they are touching us with the other intention. So we can sense just like that. This artificial muscle will sense. The next one is elastic electric cable. It is shown here in this diagram. Imagine when we design a robo, there will be many number of electrical wires connected between. Sometimes these electrical wires are really stretched. Imagine an electrical cable that is elastic. How often you stretch, the cable also will come stretch. So it is a very important thing in the design of robotic arms, in constituting various degrees of freedom and all. This electric cable is a boon in that area. The next one is tactile sensation. Tactile sensation in your skin, just like this artificial muscles. The next one is mimicking synapses in silicon. So scientists nowadays are trying to remake the human brain. So they have actually made one part of human brain successful. Synapses means some major functions of brain they have made it artificially. It is a real breakthrough in making a robo exactly like a human, an artificial man. Just like that they are doing it. And then we know that robots are not as fast as humans. So scientists have worked on, and the recent trend is robots are made as fast as humans. Then comes the artificial nose. Just like we smell, we sense various fragrances, this artificial nose can identify different perfumes, different scents, different fragrances also. The last one is really impressive. Tactile sensor. So in our fingers, our finger end point is such a sensible one. We can sense by placing our fingers in a glass of water. We can find it out whether it is hot or cold or lukewarm, isn't it? The same way, this sensor you are seeing here in this sensor can sense the object, whether it is soft, whether it is hard, whether it is medium, how much pressure I should give to lift that object or without damaging them. So imagine how each and every part of robot, just like a human, they are building on. These are all the recent technological trends in the making of a robot. Okay, the next part are when we try to start building a robot. One thing is we will go and take a Arduino board with a Raspberry Pi board with an ARM processor kit. We will be start building a robot. So we will write a program. That sort of softwares are there freely available in the internet. Then we will dump it in a chip, and then you can make it for our purpose. But for making in the design aspect, for shaping the arms, for that purpose, and also for making the movements, there are good softwares, robotic softwares. in order if you want to make a carrier, or this type of softwares are used in industries to manufacture robots. Okay, so I will list out some robotic softwares. You can just Google it and find out how far it is suitable for your nature. So one is virtual robotics toolkit. So this is a very good toolkit. The next one is visual components. The next one is Robo DK, Robo Virtual Worlds, Microsoft Robotics Developer Studio, LabVIEW, many may have been aware about that, WebBots, Robot Studio, Actin Simulation, Workspace, Algado, Robologics, RoboGuide. This list is exhaustive. What I have mentioned here is something very promising and very famous, and every company, based upon their different applications, they are using this robotics software. Okay, the next one we'll be talking about is current trends or current scenario. We are all talking about this COVID-19, and during the previous explanation itself, I am talking about many robots that have been used in the current scenario. And apart from that, what you are seeing is one is Hydonalix. This is a water rescue robot. This robot especially helps in making the people not to get submerged in the sea, helping them and rescuing them. So one example is we know that many migrants in search of better option, go from country to country, that too in a boat, especially in Mediterranean. You can see that people flee from a civil war, and people flee from the war-ravaged nations to nations which are better at infrastructure. So they will get into a boat, the boat will be overcrowded, and most of the time, when the weather goes rough, and we have heard many heartbreaking stories about that. So the one robo you are seeing here, it has rescued more than 300 people in the seas, so in the Mediterranean. So many countries are employing this robo to rescue people from the seas. So this is one thing. The next one is iRobo. When you see this also goes to places for rescue operations, for identifying earthquake victims, and for fire also. This sort of robots are used. And another one that is very much helpful for the humanity is this Colossus. This is a firefighting robot, especially in the last couple of months back when France famous cathedral was on fire. This robot was ordained to quench the fire. So imagine the power behind that. It will blast 660 gallons of water per minute. Remember our fire engines. So it just blasts 660 gallons of water. It's very huge, and it is a 1,100-pound fireproof robot. It is not affected by fire. You can imagine that most of the fire engines are prone to fire only. So these sort of robots are extensively used in the current scenario. So another thing in terms of security, in terms of the rescue operations, is aerial rescue robot. One you are seeing here, aerial rescue robot from Lockheed Martin. So you may be aware this Lockheed Martin is a company which manufactures fighter aircrafts for American Air Force. So they have designed an almost unmanned aerial vehicle or a robot which does it has a 1,000-pound cargo capacity, how much load it carries, you just imagine, to help wildfire, to deliver supplies, and everything it does. So another thing is KMAX, you are seeing this. So it delivers supplies, humanitarian aid and fuel to hard to reach locations. In some countries in Africa, they use robo to deliver medicines in remote places not accessible. So it's there some years back, and these are all the recent ones where people have improvised on. Okay, so the next thing we are going to discuss is, suppose if you want to make a career in robotics, how should I proceed? So for a student, you can either take a career in electrical engineering, you can either take a career in mechanical engineering, you can either take a career in computer science engineering, you can take a career in mathematics also. Why? Because the movement of robotic arms, the motion, the movement, everything is related with mathematics. Cartesian coordinates, time, distance, everything, it's related with mathematics. Suppose if you are a mathematics graduate having a PG degree, you can have a career in mathematics also. Also in design and technology, product design, you can design the robo also. So electrical engineer will be taking part in this actuators, how to convert this electrical energy and give more power, because it is the muscle of the robo. Mechanical engineer will be in the design aspect, what type, how many movements it should have, what will be the Cartesian coordinates, whether it should be an articulated robot, SCARA type of robot, how many degrees of freedom it should have. So computer science engineering people, computing and programming people, what type of program we can put, what type of software we can put, how I should how I can load this into or dump into a appropriate board, everything, these set of things, yeah, computer science engineer can do. So from this, one thing is very clear: robotics, the field of robotics, is not particular to any one field of engineering. It's a combination of electrical, mechanical, computer science, design, and mathematics. So these are all some major fields. So anyone who is pursuing or who is going to pursue a career can get into the field of robotics. So these are all the courses over there. So then we are coming into the last part. So the next thing is, what are all the projects as a beginner you can rely upon, you can learn. So one thing is a line following robo. Basically a robo which can be designed and which follows a particular line. Maybe a practical example is a car that runs on the road. If the car comes out of the road, it stops. So automatic, so that sort of robotic vehicle. An Warfield spying robo using a night vision camera, a metal detector robotic vehicle, an RF controlled robotic vehicle with a laser beam arrangement, a microcontroller based line following robotic vehicle, a remote controlled robotic vehicle. I have just some basic things of robotic projects for beginners. Suppose if you are into that, it's well and good. One good site is you can go into arduino.cc, where you can have some thousands of projects for even for starting from school students to engineering graduates also. And you may have seen people designing robots for coronavirus patients. Yeah, I think they are just modifying the robot for a particular application. You can see and you can hear it, see in papers, hear that the robots carry a tray and it can be managed by a person. Even a robot keeps social distancing in buying certain food, and the amount can be transferred through Google Pay. So robotics, one part, you can design that and you can control the robot through IoT, Internet of Things. So that's where this app comes into picture. So nowadays the trend is robots can be automatically programmed, or it can be remotely controlled also. So this field is growing in this area. So before I conclude, I want to tell you, in America there is one spot robo where it is shown in the first slide. I will show you. You can see here, this is one yellow color one. You can see this is a spot mini robo which is up for sale. In you can buy this robo if you need. You can see this one is a human companion. Say for example, if you are into gardening, and every time you start doing gardening, we will order some, our brother or sister or our father or someone, dad bring that, sister bring that, brother bring this tool, I'm going to do this, such sort of thing. But this can be used as a companion, so that it goes and fetches the things you require. You just instruct them, it will be with you through all environment, even if it is rain, even if it is bright sunshine, even if it is a severe cold. It is irrespective of environment, even if it is day, night also. This is a very good companion. Even during night, if you go into lawn, it has a light system where it gives an illumination also. So this one you can see over here. Okay, so robos for sale, robos for rent. Okay, so lastly, this field of robotics is developing at a faster pace, very faster pace, day by day. So what is happening today will become obsolete within another next 2, 3 or few months. In some countries it's getting obsolete, some countries the technology is coming over here. Such is the field of robotics. And you can see these robots can be used, can be given as toys for children also. In many Korean countries, robotic toys are there. It's very cheap also. Okay, so such is the field of robotics. If you have got any queries, you can be in touch with me at amarferoz@gmail.com. I welcome any queries and it will be immediately addressed also. I thank you for being with me for the last 1 hour. Okay, I wish you all the best, and I wish you be a part of this robotics, because that's one of the areas that's going to be the future in the coming years to come. Thank you.
Now I request Mr. P. Kannan, Assistant Professor of ECE Department, to give the vote of thanks.
Good morning, all of you. It is a great honor to propose a vote of thanks on this special occasion. At the outset, I thank the resource person, Mr.C.Amarsingh Feroz, sir, for having presented the webinar on robotics and automation. Sir, on behalf of ECE Department, I thank you for your wonderful webinar. I thank the management for their guidance and motivations to organize the webinars during this lockdown to make our students and other participants enrich their knowledge in the relevant field. My sincere thanks to Dr. Jayakumar, General Manager Development, Dr. Velmurugan, Principal, and Professor L.R. Priya, Professor Academic, for their support. Further, I take this opportunity to thank Professor Friska, Head of the Department, for her valuable advice and direction towards making this webinar in a grand success. I thank the coordinator of this event and all the faculty members of ECE Department. And my sincere gratitude to all the participants for your active participation. Thank you, one and all. Thank you.